Hello and welcome back to session 2 of the data interpretation course. In this session, we'll work a little more with growth rate and see applications maybe of moving forward and backward, and also revise and try to master the process of working with multiplying factors. So here we go. So for starters, let's begin with a very simple table. You can see that data for 4 companies A, B, C and D is given for sales in 1998, growth rate in the year 1999, and in some cases sales for the year 1999. Okay, and some data is missing. Your job is to find the missing data. Okay, so take your time, spend maybe 5 minutes at this and try and work out the missing values before seeing the solution. Okay, hope you had a good crack at it. So this is what we'll do. First of all, we'll label the missing values so that we can talk about them easily. Let's call the value for A 1999B, value for B 98Q, value for C 99R, and value for D 1998 as S. Okay. Next, a very important idea that you need to understand is that this growth rate is a percentage operator. Percentage data is always given in reference to a base. It is always working on a particular base. So what is the base for these percentages 12.5, 50, 5.55 and 25? Okay. The base for these rates is the year 1998 or the sales in the year 1998. So that should be very clear to you. That means to get the value of sales in 1999, that is P, I will take 560 plus increase it by 12.5% of 560 to get to the value of P. Okay, and that is also my equation if I want to figure out the value of P. So the only thing that we'll do new is replace that 12.5 by 100. Maybe by now you've got you started using fractions instead of this divided by 100 form. So that's the only thing that we'll do extra here, and I can solve this equation pretty easily. For the second equation, I know that Q was increased by 50% to get to the value of 1500, right? So 1500 is equal to Q plus 50% of Q. So that is 50 by 100 into Q. Only thing new again we'll be doing is replace that 50 by 100 by 1 by 2. Okay. Looking at the third one for company C, this 5.55% increase in the value of 1980, that means 1980 is increased by 5.55%. So 1980 plus 5.55 by 100 of 1980 will give you the value of R. Okay. 5.55, if I can remember from the previous session, is 1 by 18. So 1980 plus 1 by 18 of 1980. So replacing the percentage with the fraction might make your calculations a little bit faster. Okay. Lastly, once again, this 2000 is equal to S plus 25 by 100 of S, because S was increased by 25% and then you get 2000. Okay. So this is the equation. So I'll leave the solving of the equations to you, so you can figure out the values of P, Q and R and S. Okay. But what we want to do is, this was the standard way. The only thing extra we did was replace the percentage with fraction. We want to use the multiplying factor method. So we will start by revising what they are, how they work, how to form multiplying factors, and then we'll come back to this table and see maybe can we do this kind of calculation, because this will happen a lot in a lot of DI sets faster. Okay. Okay. So let's start with very basic, easy ideas. If I were to ask you find 25% of 296, you will do it very easily. You will say 25 by 100. All I'm saying is that think of 25 by 100 as a habit as 1 by 4, and your calculation becomes 1 by 4 into 296. Okay. In this case, you can quite see the cancelling. 25 by 100 reduces to 1 by 4, so you don't have to think too much. Okay. So find 10% of 296. Similarly, would be 10 by 100 of 296. I know that can be easily cut down or reduced to 1 by 10. Let's try one more. 12.5% of 296. Now this division might not be very clear, so that's why memory helps. If you can revise these and repeat the concepts in your head a few times. 12.5% is 1 by 8. So 1 by 8 of 296 is the same as saying find 12.5% of 296. Okay. So that's the idea that we want to see here. That when we say find 25% of 296, and it is the same as saying multiply 296 by 1 by 4. or finding 10% of 296 is the same as saying multiply 296 by 1 by 10, or find 12.5% of 296 is the same as saying multiply 296 by 1 by 8. Okay? So these are the fractions that we looked at in the previous session. Just take a look at them again so that when we start using them, you're slightly familiar with them. So slightly difficult fractions would be, let's say if I were to ask you to find 5.55% of 296. What I want to do is, instead of writing that 5.55 by 100 into 296, I want to directly move to this step, and that will be possible if you know these numbers by heart. Okay. Similarly, find 6.66%. 6.66% is 1 by 15, so finding 6.66% of 296 is the same as multiplying it by 1 by 15. 87.5% of 296 is the same as multiplying it by 7 by 8. Now, how did I come to this? I remember that 1 by 8 is 12.5 and 87.5 is a multiple of 12.5. Okay, or I can think of 87.5 as 100 minus 12.5, or 1 by 8 less than. So 7 by 8 into 296. Okay. Similarly, 36.36%, the value would be 3 by 11 into 296. How? I see that the number is repeating 36 and then 36 again. Any such number normally has a denominator of 11 in it. Okay. Sorry, it should not be 3 by 11, it should be 4 by 11. This is an errata, so please check it for yourself. 36.36 should be 4 by 11 of 296. Okay. So I hope you get the idea. This is how the basic fraction percentage equivalence works. Okay. Now we're also interested not only in finding percentages, but percentage increases and percentage decreases. Okay. So how will that work with multiplying factors? So let's say there is a number n, and I ask you to increase it by 12.5% and get to n dash. So it will result in a very basic equation. N dash is equal to n plus 12.5 by 100 of n. Again, just that 12.5 by 100 I can replace by 1 by 8. That much I think should be very clear by now. Now I can work out this equation. It will result in n dash is equal to 9 by 8 of n. Yeah. Or trying to increase n by 12.5% is the same as multiplying it by 12.5. In both cases you get to n dash. Okay. In case you're struggling with getting from the first equation to the second, the shortcut would be to think like that. The equation that you have to work on was n plus 1 by 8 of n. Just think of the initial n as 8 by 8 of n, because the 8 by 8 will get cancelled and you get n back. So now you can see that the denominator is the same, so it's just about adding the numerator, so your value becomes 9 by 8. Let's try one more practice round of doing this, of forming multiplying factors. Let's say n was increased by 11.11%. So n dash will be n plus 11.1 by 100 of n. Yeah. 11.11 by 100 can be reduced to 1 by 9. Okay. So n dash is equal to n plus 1 by 9, which will result in n dash is equal to 10 by 9 of n. Okay. Once again, the shortcut or the pen without pen and paper method would be, think of n as 9 by 9, and 9 by 9 plus 1 by 9 becomes 10 by 9. Okay. So increasing n by 11.11% is the same as multiplying it by 10 by 9. I leave this example to you. Just quickly go through it and see if you understand the process that is happening or not. Let's try for percentage decrease. Let's say the number n was decreased by 12.5%. That means the new value of n dash is n minus something. And minus what? Minus 12.5 by 100 of n. And I know 12.5 by 100 is the same as 1 by 8. So n minus 1 by 8 n, which can be reduced to n dash is equal to 7 by 8 of n. In case, once again, the shortcut method will be, think of n as 8 by 8, and 8 by 8 minus 1 by 8 should be fairly easy once again. So answer you get to is 7 by 8. Eventually what we want to do is, we don't want to take these first, second and third steps. We finally want to get to this n dash is equal to 7 by 8 and do it pretty quickly in our head without the need for pen and paper. Okay. N was decreased by 11.11%. Let's fasten it up. 11.11% is 1 by 9. So N minus 1 by 9 would become 8 by 9. Okay. Let's try one more example. Let's say it was decreased by 5.26%. 5.26% is 1 by 19. So N minus 1 by 19 of N, yeah, that would become 18 by 19 of N. I hope this is making sense to you. Now, eventually, what we want to do is we don't want to take these first writing down the whole equation. What's the point of doing it? We just want to convert this language information into a multiplying factor. So maybe this visualization will help. N is increased by 7.14%. I know 7.14% is 1 by 14. An increase of 1 by 14, that means my multiplying factor would be 15 by 14. This is what we should be able to do if we want to develop some serious speed in our calculations and percentage calculations. Similarly, for the second value, N is increased by 5.88%. 5.88% is 1 by 18, 1 by 17. So an increase of 1 by 17, that means my multiplying factor would be 18 by 17. Okay. This should also help you visualize that n is the base and n is being multiplied by 15 by 14 to get to n dash. Okay. Very soon we'll be moving from n dash to n. It will make more sense then. See if you understand the movements for the rest of the percentage to multiplying factor information. Just a few examples to work with. Okay. Okay, so hope you were able to make sense of that. Let's move forward and work with, let's add some extra information to this kind of working, okay? So let's say the number n is increased by 12.5%, but there is an added question this time, and the question is, now n is what percent of n dash? If I know that n dash is 12.5% more than n is what percent of n dash, okay? So I already have that n dash is equal to 9 by 8 of n. All I have to do is flip the multiplying factor or find the reciprocal of it or cross multiply it on both sides and I'll get this form. So I'll get n is 8 by 9 of n dash. 1 by 9 is 11.11%. So 8 by 9 would be 88.88%. Okay. Or you can split the fraction just the way you were adding two terms to get to a fraction. You this time split the fraction. Think of it as 9 by 9 minus 1 by 9. 9 by 9 is 100% and 1 by 9 is 11.11%. So n is 11.11% less than n dash. Okay. In this case, it should be 9 by 9 of n dash. That's an errata here. Let's try one more example. N is equal to 296. We're not really interested in the value. Let's say n was increased by 11.11% to get to n dash. And the question is, n is what percent of n dash? Okay. I know from the first part of the question that n dash is 10 by 9. All I have to do is flip the multiplying factor and I get n is equal to 9 by 10 of n dash. 1 by 10 is 10%, so 9 by 10 would be 90%. So n is 90% of n dash. Yeah. Or I can split the fraction and n will become 10 by 10 of n dash. Once again, that n there is an errata. 10 by 10 of n dash minus 1 by 10 of n dash. Okay. So that means n is 1 by 10 less than n dash and 1 by 10 is 10%. So n is 10% less than n dash. Of course, you could have just reduced this from the first language also. If you know that n is 90% of n dash, you know n is 10% behind n dash. Okay. I leave this particular example for you to work out and see if you can understand the interpretation or not. Once again, in the second equation, the n should be n dash. Okay. Let's try out for a percentage decrease, just for practice sake. So n is decreased by 12.5%. I know that will be 1 by 8 decrease. That means n dash will be 7 by 8 of n. All I have to do once again is just flip the multiplying factor and I get n is equal to 8 by 7 of n dash. Now 1 by 7 is 14.28. So 8 by 7 would be 114.28% of n dash. Now how did I come to this calculation very quickly? I understood that it is 1 by 7 extra or 7 by 7 plus 1 by 7. 7 by 7 would be 100% and 1 by 7 would be 14.28%, so 114.28%, which also tells me that n is 14.28% more than n dash. I'm sorry for the inconvenience, but in the bottom right corner, this last equation, it should be n dash. N is equal to 7 by 7 n dash plus 1 by 7 of n dash. Sorry for the trouble. Let's try one more example. N is decreased by 7.7%. And remember, this is also an excuse to revise a reciprocal. So 7.7 is 1 by 13. So n dash is 12 by 13 of n. All I have to do is flip the multiplying factor. It becomes 13 by 12 of n dash. And if I have to work it out, it will be 108.33% of n dash. Again, how did I come to that so quickly? I know 1 by 12 is 8.33%. And this fraction can be split into n is equal to 12 by 12 plus 1 by 12 of n dash, and 1 by 12 is 8.33, which also tells me that n is 8.33% more than n dash. Okay. This is how I would visualize. Let's say if the multiplying factor from n to n dash is 15 by 14, these are the interpretations. N dash is 107.14% of n, or n dash, again that n should say n dash, or n dash is 7.14% more than n. That means I don't want to form this whole equation. I should be just able to see the multiplying factor and come to the percentage interpretation. Similarly, if I flip the multiplying factor and I go back from n dash to n, the multiplying factor is 14 by 15, which means that n is 1 by 15 less than n dash. 1 by 15 is 6.66%. That means n is 6.66% less than n dash, or is 93.33% of n dash. I subtracted 6.66 from 100 to get to 93.33. Okay, instead of multiplying 6.66 by 14. See if you can do the same interpretation for the rest of the multiplying factors in both directions. That means you should be able to express n dash in terms of n and n in terms of n dash. Okay. Okay, finally let's get back to our original table and see whether what we have learned can add to some speed in our calculations or some conceptual clarity and elegance in our solutions. Okay, so let's work with these values. I have 560 and 12.5%. This 12.5% means that 560 has grown by 12.5%. My multiplying factor method very easily tells me that means it is the same as multiplying 560 by 9 by 8. So my calculation gets reduced to only this one operation, 560 into 9 by 8. The rest of all the things are already in my brain, like that 12.5% is 1 by 8 and 1 by 8 increase means 9 by 8. All of that should be part of my thinking already. Okay. Similarly, for the same process, Q has been increased by 50%. That means a multiplying factor for Q is 3 by 2. But we don't have the value of Q, we have the value of 1500, from which we have to figure out the value of Q. So let's flip the multiplying factor, because we have to move backwards using the growth rate. So this 3 by 2 will become 2 by 3. This forward and backward movement may happen a lot in DI sets. Okay, so it's better to just learn this process in one go and come up with these multiplying factors and what has to be done, whether they have to be kept straight or flipped around. That decision should be made very quickly. Okay. Similarly, 1980 and 5.55%, I just have to move ahead. 5.55% is 1 by 18. That means 1980 has to be multiplied by 19 by 18. I hope you understand why. And lastly, S has increased by 25% to get to 2000. That means the multiplying factor for S should be 5 by 4. This 3 by 2 is incorrect, it's an errata. And going back from 2000, the multiplying factor would be 4 by 5. Okay. I hope you ignore this 3 by 2 and 2 by 3. In the last column, it should be 5 by 4, and from going from 2000 to S should be 4 by 5. Okay. So I hope the calculations are pretty easy. Okay, that's it for this session 2. I hope you really learn and master the multiplying factor process, because it can add to a huge amount of speed in your working out percentage calculations and ratio workings. Okay. I leave with you a couple of questions to think about till the next video comes out. See you soon, and thank you.